Hello, my name is Uwe Hartmann. I'm CTO of Image Engineering. IEEE-P2020 is the standard for image quality in automotive systems. It's the first international standard in this topic. So how can it help you? Let's have a look at that. So now have a look at another image quality factor. So one is the dynamic range. So typically, dynamic range is defined as a ratio of the maximum luminance and the minimum luminance that a system under test can reproduce. So the maximum is then defined by saturation, and the minimum is defined by the signal-to-noise ratio. Typically, you say when the signal-to-noise ratio equals 1, you have a loss of information, and that's the lower limit, minimum luminance. The problem is, if you have, for example, flare or other effects that reduce the contrast, which you can easily have in HDR images, the SNR will actually get better. And therefore, also your measured dynamic range gets better. And that can lead to misleading results. So that means that the traditional way to measure dynamic range has its challenges, to say the least, for automotive-grade cameras. Therefore, IEEE-P2020 addressed that, and there's the definition of CNR, the contrast to noise ratio. So the idea is that we not use the mean value divided for SNR, the mean value divided by standard deviation. We take the contrast between two patches. And now you see, two patches. That's something that sounds familiar as we had with CTA measurement. And yes, that is something that you can do as well. So in the document of the P2020 and in the development, there is a test target that is limited to a default contrast of 2:1. And during the development of the standard, it turned out that the used targets were varying a lot, which caused issues in reliability and repeatability of the results. So there were single patches that did not have the contrast that it was supposed to be, or that there were some color issues in there. So that's why we checked how can we do it differently. And with in the data that we get for CTA and CSNR measurement, what I just talked about as contrast performance indicators, we can also calculate the CNR. And with that, you can get the CNR not only for the 2:1 contrast, but also for any contrast. And that is a big benefit, so that you can calculate your dynamic range flexibly for different contrast, but it is compliant with the standard. So that looks like this. You have, again, a map. On the x-axis, you have the average luminance. On the y-axis, you have the contrast. And then in color, you have your CNR. And now, according to the standards, it's 2:1 is that shall be used, but others are definitely a possibility. So now you just have a look at a third Michelson contrast, so 0.33. That is where you need to have a look if you want to know about, according to the standard, what's the dynamic range. But now with this approach, you can also check at other contrast. And that is definitely a benefit, because if you have a task like a road sign detection, it's higher contrast task than you want to do a pedestrian detection, where you need to check like a person with dark clothes in night time and so on. So that's a different test. Something to talk about dynamic range. So today's sensors, high dynamic range sensors, they need a very bright light source to check the limits, especially when you want to bring them to saturation. So sensors are typically configured that way that it's okay to have the sun on the horizon in the image. That might bring it to saturation, but only that. So that means if you want to simulate this in the lab, you need a very bright light source. And that's why we introduced Arcturus. Arcturus is a light source that works well together with the Vega light sources that you've just seen in previously. And that is what what is so bright that you can actually bring automotive grade sensors into saturation. So we are about 1 megacandela per meter square, while still being very stable and consistent. So you can go over a huge range of dynamic range, change the intensity of that light source, and perform tests with a high stability. So the device itself will control itself and will be very stable. It's flicker-free, and you can use that also with very, very short exposure times. If you need flicker for checking, feel free. There is flicker simulation if needed, so you can put a flicker signal onto that, but per default, it's flicker-free, DC-driven, so you can do a lot of tests on that. So especially, you can combine that with the Vega and the Arcturus, and with that you can scan through a huge dynamic range for imagers and really get into the details throughout the entire range of imaging with your camera.